Hey there. So I screwed up the other video. I'm going to have to do this again. What a shame. But this is the video on compound circuits. Compound circuits are circuits that include some series and some parallel. So here I've drawn a circuit, and let's just make sure it has some series and some parallel. When current comes out of the battery, it has to go through this resistor. That means this resistor is in series. But then when we get to this point in the circuit, we have a choice of going down this way or this way. And a choice is a hallmark of parallel. So these two are in parallel, and this one's in series with either this one or that one. And we're going to solve this using a method that I call the bootstrap method, where we're going to draw a bunch of different circuits that are ever simpler, solve the simple circuits, and work backwards towards the original circuit. So the first thing we can do, and by the way, my philosophy on this is to always try to attack the circuit from away from the battery and work towards the battery. And I also like to get rid of parallel wherever possible. So both of these things are true. I can take care of these two that are in parallel. So I'm going to draw another circuit here. And this circuit is going to have the same size battery. And we're going to leave the 2 ohm resistor alone. But we're going to replace the parallel combination with a new resistor. So 50 volts, positive terminal. We need a new number here for this. And what is the equivalent resistance of 2 16s in parallel? Now you might know the trick, which is when you have two of the same resistor in parallel, that the overall resistance, or the equivalent resistance, is half of one of them. But let's verify that. We're going to put in 16 and hit the 1 over button, and then add to that 16 and hit the 1 over button, and we're going to get an answer for that. And this is not the answer for the equivalent resistance. This is the inverse, so we have to do the 1 over of the answer, and we do get 8. So this is equivalent to an 8 ohm resistor. From this point, the circuit is really easy to figure out. The next equivalent circuit would be one that has the same size battery and just a single resistor. And this resistor would be a 10 ohm resistor, because this circuit is a series circuit, and in series circuits the equivalent resistance is simply the sum of the two resistors. So this is our basic, most easiest circuit, and from this we can figure out first the current that flows out of the battery. I'm going to use this greenish pen for that. The current that flows out of this battery is going to be the voltage of the battery divided by the equivalent resistance, which in this case is 50 divided by 10, for a grand total of 5 amps. So now we know that 5 amps flows out of the battery, and since the only resistor for it to go through is this one, this resistor is going to have 5 amps flowing through it. And once we know for any given resistor 2 of the 3 things, we can use Ohm's law to find the third. Here we're going to find the voltage being dropped by this resistor, and that's going to be the current times the resistance, which is going to be 5 times 10, or a grand total of 50 volts. Now that should not have been surprising, because there's only one resistor in this circuit, and the voltage from the battery is 50 volts, so this has to dissipate all 50. So the charges have 50 volts when they come out, they lose 50 going through here, they go home with 0 volts. And now we know all 3 things about this resistor. And you might argue that this resistor doesn't really exist, and you're absolutely right, but it has some utility because we can take some information back. When we're taking back information, we have to ask ourselves, what are we going back to? And we're going back to a series circuit. Series circuits have the same current everywhere, so we can take this current value of 5 amps and we can apply it to both of these resistors. And now that we know the current and the resistance for each of those resistors, we can calculate the voltage, which is simply the product. This one is going to dissipate 10 volts, and this one is 5 times 8, which is 4 times 10, or 40 volts. And 10 plus 40 does add back up to 50. So the charges coming out of the battery would have 50 volts. They would lose 10 and be down to 40. Then they would lose 40 more and be down to 0 when they go home, and that is correct. Well, these bits of information here for the 2 ohm resistor are true for this 2 ohm resistor, because that's really in our circuit. So we can put our 10 volts and our 5 amps here. Let's get rid of that. No mistakes were made. Now we have to take some of this information and bring it back to these two guys. When you're coming back to a parallel arrangement, parallel resistors have the same voltage but might have different currents, so we bring the voltage back with us. 40 volts will be dissipated by this resistor, and 40 volts will be dissipated by this resistor. From that, we can find that the current is going to be the voltage divided by the resistance. Now here, it's not exactly easy, it's not an even number, but it does work out to be 2.5 amps. 2.5 amps, and that's not surprising because we have 5 amps coming into this location, and it's going to split equally because they're equal resistors. That's 2.5 each. So now we know everything there is to know about this circuit. The only thing we could possibly do further would be to calculate some powers, and powers are voltages times currents, and since we know voltage and current, we could certainly do that. Let me show you how to solve this exact same circuit using a different technique, and this is the table technique. The table technique. And here in the table technique, we simply go through 50 volts. We simply go through the circuit and try to identify these things. Now my table has columns for the resistance, the current, the voltage, and the power. As far as the columns go, the power column is easy. Once you have these two filled in, you simply multiply them together to get the power. And as far as voltage goes, voltage is going to be current times resistance. So if we need voltage and we've got current, we just multiply these two. However, if we've got voltage and resistance and we need current, we're going to have to divide. And the rows are one row for each of the resistors in the circuit and a separate row for the whole circuit.